In this section, we're going to be working on topic 3, solving applications with systems of two equations. And we'll be doing total value problems, mixture problems, and motion problems. Now, all of these relate, and they're different words, but there's a lot of basic things running through. So as you get one and master it, that should help you with doing the next one. One of the first problems we work with, or the kinds of problems, will be distance problems, in which we use the formula distance equals rate times time. We'll be getting to that here shortly. And then the other that we mentioned earlier was interest problems, where interest equals principal, amount of money you invest, times the rate, the percentage at which you're going to earn money, and the time. So let's get these in the right place. We'll pause. Again, we've gone over these, but as a double check. Okay, now we're going into converting English into algebra. Okay, as we read number 3, the sum of two numbers is 90. So we had some like this, x plus y equals 90. The first number, which is x, is, which is an equal sign, 2/3 of the second number. Y is the second number. So there's our two equations, and this lends itself very easily now to substitution. So where I have the x, I have put this value for y right there. And there's my y and 90. So there's the first equation. I'm taking this and putting it right there. Substitution. Now, to get rid of the fractions, a technique from chapter 1, I'm going to multiply every term by 3. Here now the 3's cancel out, and I'm left with 2y plus 3y equals 270. Group like terms. Divide both sides by the numerical coefficient of our variable, which is 5. Y equals 54. Then put the y for 54. Solve for the x. X is 36. Now remember, when you give this answer, this is written as an ordered pair. So the answer would be 36, 54. In number 4, again, this is still pretty easy. Two angles are supplementary. So here they're telling you that the sum then of two angles is 180. Then they're saying one angle, which is x, is, which is an equal sign, 15 less than twice the other. Well, twice the other would be 2y less 15. So twice the other less 15, right there. Now this is a value for x. So what I'm going to do here, I'm going to take this value for x, put it right there. And that's what I've done. So there's the value for x plus y equals 180. Now I have an equation with just one variable, which I now solve. Group like terms, transpose the negative 15, I get this. Divide both sides by 3, I get this. That is my y value. I then put it there. I solve for x. X is this. Now, as we do these, it's good that you're seeing them done, but again, you want to be able to do it yourself. Now, I may not solve every single one, but I will give you the equations because that's what you want to do. And the equations are just repetition of what we've done before. Okay, as we go on now to number 5, you have a supper being served, and they served 325 dinners in all. Now, some of those were a child's plate, and some were an adult's plate. So, first equation, the number of adults plus the number of children equals, and let's get the right number there. I see I have that incorrect. That's why it's always good to check your work. Let's put a 25 there. I read that as 350 at first. And I need to change it over here too. Okay, so, and then they took in this amount of money. So, as we look at this, then, what does the adult plate cost? $6. So $6 times the number of adults that were there, and then the child's $4.50 times the number of children that were there, gave you a total of this. So these are your two equations, that the number of adults plus the number of children were 325. So then what would be your strategy to solve? Well, you might use substitution, where you're going to solve for the letter A. So A equals 325, transpose the C over, and I gave you a negative C. So now this is what your A is. You then are going to put this over there and substitute it for the A. But before you do that, I would strongly suggest you get rid of your fractions by multiplying every term by 100. Now you don't have to worry about the decimal points anymore. Okay? Now when you solve all of this, you will find that A equals 140 and C equals 185. Now if I did all of these, the tape would be very, very long. But what I want to show you on this tape is the technique to get from English to algebra and then solve it. Going on to number 6 now, it's perimeter. Well, there's the perimeter formula. So all we have to do is say, there's the perimeter, we put that in there. So there's our first equation. Now our second equation says the length, which is L, is, which is an equal sign, 4 meters longer than twice the width. So twice the width is going to be 2W plus 4. And keep that in a parenthesis because that's a sum. That's what L is. So now you're going to take this and put it where L is. So then you go 2 times this, which is now in terms of W, plus the 2W equals that, and that's how you get your W. Then you plug in your W into either of these equations, and then you find the length. All right, you'll notice that examples 7 and 8 follow a pattern that we've set up. So here we have two types of candles, a 16-ounce candle and a 24-ounce candle. Now, if they were different letters, candle is C, so you can't use the C's. So I'm identifying then the 16-ounce candle as X, the 24-ounce candle as Y. And we sold 82 candles. So X plus Y equals 82. Now, what does the X candle cost? Well, this. What does the Y candle cost? This. And the total amount they took in was this. So there are your two equations. And once again, the first thing I would suggest, get rid of all these decimals by multiplying each term by 100. And now you have an equation without decimals. Then I'm going to solve for one letter. Let's say X. So X is, transpose the Y, is this. So I'm now going to put this where the X is, and then grind it out. And for number 7, again, the answers are in the back of the book. There's going to be 34, that's what X equals, and Y equals 48. Now remember, you can get help on this in the 5th floor of the library, the Learning Center, and or before or after class. Number 8 is very, very similar. We have dried apricots that sell for this, that I'm going to classify as X. Dried apples that sells for this, that I'll classify as Y. And you want to make a mixture that is 40 pounds. So X plus Y equals 40. This is what the X cost. This is what the Y cost. And you want to make a mixture that costs this, and it's 40 pounds. There are your two equations. And again, get rid of the decimals. Now, each of these equations, you're going to have to spend 5 minutes on them. These aren't 2 plus 2 is 4 that you get done in an instant. These take time, and that's the nature of college math. They want you to think about it. They want you to think about it some more. They want you to write an equation. They want you to problem solve. That's the skill we're doing. Now, on a test, we're only going to give you one problem, or there may be two. So we're not going to ask you to spend hours and hours. There'll be other techniques that you'll need to know for the test. But again, as you sit and study, you are trying to master the skills involved here. Again, they are following in a pattern. Here we have alpine trail mix that I'll call A, meadow trail mix that I'll call M. And we want to get a 10-pound batch. So A plus M equals 10. Now the alpine mix is 40%, so 40% of A. Meadow mix is 25%. 25% of M will equal what you want to end up with, 32% of your 10 pounds. So you might say, well, how do I start to solve this? Well, you're going to say A equals 10 minus M. You solve for A. And you're going to get rid of all your decimals. And then you're going to put this in parentheses where the A is. And crank it out. All right, Whitney has 2 student loans totaling $14,000. We're going to say the one at 5% I'll call A, and the one at 8% I'll call B. So we know again, A plus B equals 14,000. Now the A is at 5%, so 5% of A plus 7% of B earns the interest of this much money. Again, with all these little decimals, you want to get rid of them. So I'm going to multiply everything by 100. Now here I had to add 2 zeros. So I could multiply this by 100 as well. Now I don't have decimals anymore. Now where I have the A, I'm going to put this. And in fact, I'm going to do this one for you. Okay, so what I did is I said then, after I got rid of my decimals, 5 times A, which is this, is 5 times that, plus 7B. 7B is 85,000. So I distributed that, and I get this. I group my like terms. I get 2B, or not to be. Well, I'm subtracting 70,000, or transposing, and I end up with 15,000. Divide both sides by 2. I get B equals 7,500. And remember, B is at the 7%. So I subtract that from 14,000, and I get 6,500 at 5%. So again, all of these, can be worked out. The answers are in the back. What we're interested in doing here is seeing the strategy of being able to convert from English into algebra. And hopefully you're seeing a pattern that you can duplicate. Okay, as we go on to number 11, this is similar to what we've done before. So tropical punch, T, Caribbean spring, C, and they together you want 18. So T plus C equals 18. So what's the mixture of tropical? 18%. C, 24%. And the mixture you want to get? 20 and of 18. And there are your 2 equations. Get rid of the decimals, solve for one of the letters. I think substitution would be very good. Okay, now for number 12, we are changing the nature of what we're doing a little bit. Here's a moving van, and I've read it a couple of times. The moving van is traveling at 50 miles per hour. Later, a car is going to go, and it will travel at 70 miles per hour. And they're leaving from the same place. And what they're wondering is, when will they catch up to each other? And how far would they travel? So for this, we're using the basic formula distance equals rate times time. And what do we know? Well, can you see that the distance is going to be the same? So basically we are having here, let me write it over there for you. Had a little phone call coming in. Okay, so going on, we have distance equals distance. And part of this is the formulation of what we're doing. So what did we say distance was? Well, distance was rate times time and rate times time. And believe it, we have it right there. So the van's rate will be 50 times t, because we don't know the time. But for the car, its rate is 70, and its time, again, it's the sum of the time, is 1 hour less, because they left 1 hour later. So its amount of time is going to be 1 hour less. So it's 70 times t minus 1. So what do? Well, we have to distribute the 70, which we did. I transposed the 70t to the other side, became a negative 70t. I end up with a negative 20t equals a negative 70, divided both sides by a negative 20 here. And then these just cancel out. I get a positive 7/2, or 3.5 hours. That's what my t is. But they don't want to know t. They want to know distance. How far from the rest stop? So here you have to take it to another step, where you then go to one of the formulas, let's say here. 50 times the time, which is 3.5, is 175 miles. Now, that is your answer statement. How far from the rest stop will the car catch up to the van? At 175. Now, again, there's lots of math in here, and I would expect if you're starting from scratch, it might take 20 minutes. But again, we're trying to show you what's going on. Now, in this case, by the way, we're not using two variables. And let's continue. I'll do this one in two parts, because this relates to the one we just did, where someone's in a boat and they're going downstream for 2 hours. And the rate of the current going in this direction downstream is 4 miles per hour. Now, the return trip covering the same amount of distance takes 3 hours. What was the speed of the boat? Now, we know the distance is the same. That's similar to what we just did. And that distance is rate times time. So what is the speed of the boat going downstream? Well, it would be the speed of the boat by itself in still water plus the speed of the current. So we don't know that rate, but there's the speed of the current. So that's its rate going downstream along with the current. And it has to be in parentheses since it's a sum. Now going upstream, it has its same rate in still water, but now the current is going against it. So its rate going upstream will be R, the rate of the boat in still water, minus the speed of the current, which is 4. Again, that's a sum, or in this case, we're subtracting. But that's in parentheses. So we distribute to clear the parentheses. We bring the 2r over to this side as an r ending, and then add 12 to both sides. We get r is 20. So there's our answer. The rate of the boat in still water is 20. So 20 plus 4 is 24. That's 2 times 4, 48. This is going to be 20 minus 4 is 16. And 3 times 16 is 48. So this one really checks out. So even though initially it looked rather difficult, again, the use of a diagram, trying to understand what's going on, and then applying the needed formula and knowing how to work with it gave us our answer here. Hopefully you're starting to pick up on what's going on here. Here we have a television network plays 40 commercials of two different kinds of spots, 30-second and 45 seconds spots. So we'll designate the X for 30, the Y for 45, so that X plus Y equals 40. Now here they're saying you have, during a game, 24 minutes for commercials. And this is in minutes. So what you have to do is convert 24 minutes to seconds. So they'll be in line with these numbers here. So it's 30 seconds of X, 45 seconds of Y equals this total number of seconds during a game for commercials. Those are the two equations. I would suggest substitution, solving for either X or Y. For number 15, we have personalized cells graphics. We're going to call the graphics X, and the ringtones Y, and they sold this many of them. So X plus Y equals this. Well, the graphics are $2, the ringtones are $2.50, and they took in this amount. So do you see the pattern going on here? So once again, I would suggest that you get rid of the decimals. And I had to add 2 here. Again, this is where students often make an error, failing to put the decimals there, then use substitution. Now, I have to say that in a few of these, as I went along, I did some right from just reading it and putting the stuff on the computer screen. But in others, I had to take a piece of paper and kind of do some thinking. Okay? So in this one, it's a good example. Here, this person made this purchase from $20. So how much change did she get? Well, $20 minus this gave me $7.55. So this was her change. And they say they gave it to her in dimes and quarters, D and Q. And there were 38 coins in all. So there's your first equation. Now, how much is a dime worth? 10 cents. A quarter, 25 cents. And this was the total. So the first thing you're going to do, I think, would be to get rid of the decimals. And then solve for either D or Q, and then substitute, and that'll give you what you need. And again, all of the answers have been in the back of the booklet here. and there were 25 quarters, and there were, let's see here, 13 dimes. Okay, well, that wrapped this up. Now, I spent a lot of time doing this, and hopefully it's helpful for you and that you're trying.